Welcome to Astronomy Daily, the podcast bringing you the biggest news from across the cosmos. I'm Avery.
And I'm Anna. It's great to have you with us. Today, we'll be looking at Google's ambitious plan to build data centers in space, a dangerously close encounter between two satellites in orbit, and a new theory that a rogue planet may have reshaped our entire solar system.
Plus, we'll explore how Mars might be secretly influencing Earth's climate and celebrate an incredible new milestone for the legendary Voyager 1 spacecraft. Let's get right into it.
Ready when you are?
So, Anna, our first story sounds like it's straight out of science fiction. Google wants to put data centers in space. It's called Project Suncatcher.
It does have that futuristic feel, but the reasoning behind it is actually very practical. On Earth, data centers consume an immense amount of electricity, and a huge portion of that just goes to keeping them cool.
Right, so the idea is, in space, you've got unlimited solar power, and the cold vacuum is a perfect and free cooling system.
That's the core concept. They envision a constellation of satellites, each equipped with powerful TPU chips, forming a distributed data center in orbit. They're planning to launch the first two prototype satellites in early 2027 to test the idea.
But it can't be that simple. I imagine space throws a few curveballs at sensitive electronics.
Several big ones. Cosmic radiation is a constant threat that can corrupt data and damage hardware. Thermal management is also more complex than you think. You have to actively radiate heat away from the sun-facing side.
And I'm guessing the launch costs aren't cheap.
They're astronomical. So even if the 2027 demonstration is a success, Google is very clear that this is just the first step in a project that could take decades to realize. It's a bold, long-term vision.
This is a developing story, so we'll be sure to keep an eye out for updates.
Speaking of crowded skies, our next story is a bit of a cautionary tale. A recently launched Chinese spacecraft from a Kinetica 1 rocket had a very close pass with one of SpaceX's Starlink satellites.
Okay, how close is very close when you're in orbit?
The two came within 200 meters of each other. At orbital speeds of thousands of miles per hour, that is an incredibly small margin for error. A collision would have been catastrophic.
Wow, so what went wrong?
SpaceX used the incident to highlight a growing problem, a fundamental lack of coordination and communication between different satellite operators. Low Earth orbit is becoming dangerously congested.
I believe it. The number of satellites has just exploded in the last few years.
It has. We're now at about 13,000 functional satellites, which is a huge jump from just 3,400 back in 2020. Most of that increase is from Starlink.
And don't the Starlink satellites have an autonomous collision avoidance system?
They do, and it performs thousands of maneuvers, but the system is only as good as the tracking data it has. When new, uncoordinated objects appear, it makes the situation far more dangerous for everyone. This is the exact scenario that could lead to the Kessler syndrome,
where one collision creates a cloud of debris, which causes more collisions, creating a feedback loop until orbit is unusable.
Precisely. This near miss serves as a stark warning. Better international space traffic management isn't a luxury anymore. It's a necessity.
All right, let's journey from the chaos of the near future back to the chaos of the distant past. I love these stories. A new study proposes that a rogue planet may have completely rearranged our early solar system.
It's a really compelling idea that tries to solve a long-standing puzzle called the giant planet instability.
Okay, what's that?
Well, evidence suggests that the giant planets, Jupiter, Saturn, Uranus, and Neptune, didn't form in their current stable orbits. Billions of years ago, they went through a violent reshuffling, with their orbits shifting dramatically.
Right, and this instability event explains a lot of weird things about our solar system, like the structure of the Kuiper Belt and the existence of Jupiter's Trojan asteroids.
Exactly. But the big question has always been, what kicked it all off? This new research ran simulations and found that a close flyby from a wandering substellar object could have been the trigger.
So you mean a rogue planet or something even bigger just drifted through our cosmic neighborhood and stirred the pot?
Essentially, yes. The simulations show an object between 3 and 30 times the mass of Jupiter, so a super Jupiter or a small brown dwarf, passing through the outer solar system could have provided just the right gravitational nudge to send the giant planets into that chaotic dance that ultimately shaped the solar system we see today.
That is amazing. To think that the layout of our home is potentially the result of a chance encounter with a cosmic wanderer billions of years ago.
And speaking of cosmic connections, our next story suggests that one of our neighbors has had a much bigger influence on us than we thought. It turns out Mars may have been secretly pulling the strings on Earth's climate for eons.
Mars? But it's so much smaller than Earth. How could it have such a big impact?
Through the subtle, persistent tug of gravity, a new study analyzed deep-sea sediment cores, which hold a record of Earth's past climate. They found that the gravitational interactions between Earth and Mars appear to amplify long-term climate rhythms here on Earth.
What kind of rhythms are we talking about? Like seasons?
Much, much longer. The study focused on the 100,000-year cycles that are strongly linked to the coming and going of our ice ages. These are primarily driven by predictable changes in Earth's orbit and tilt, known as Milankovitch cycles.
Okay, so where does Mars fit in?
The combined gravity of Earth and Mars creates a sort of resonance in the solar system, a grand cycle that repeats every 2.4 million years. This resonance amplifies the effects of the Milankovitch cycles, making the swings between glacial and interglacial periods more pronounced.
So the red planet is helping to dictate our ice ages? I always think of the sun and moon as the big players, but I never would have guessed Mars had a say. The solar system is more interconnected than I thought.
It's a beautiful reminder that no planet is an island.
For our final story today, we're heading out of the solar system and into the vastness of interstellar space. The legendary spacecraft, Voyager 1, is about to hit an absolutely staggering milestone.
This one is truly mind-bending. In November of 2026, Voyager 1 will be 1 light day from Earth.
1 light day. Let's put that in perspective. That means a radio signal, traveling at the absolute fastest speed possible, the speed of light, will take a full 24 hours to travel from Earth to the spacecraft.
And then another 24 hours for a reply to get back to us. That's a 48-hour round trip just to send a command and confirm it was received. The distance is almost incomprehensible.
It really is. And to think, it launched in 1977. It's the most distant human-made object still operating on 1970s technology.
It's an absolute marvel of engineering. It has overcome so many challenges over the decades, including a very serious memory failure just recently that the team at NASA managed to diagnose and fix from nearly 24 billion kilometers away.
That's like performing remote surgery from across the solar system. Unbelievable. And it's still sending useful data?
It is. It's our only direct source of information about the interstellar medium, the space between the stars. Unfortunately, its nuclear power source is slowly fading. It's expected to go silent for good sometime in the 2030s.
But even then, its journey isn't over. It will just keep drifting through the Milky Way forever.
Exactly. A silent ambassador, carrying its golden record with the sights and sounds of humanity. It will likely outlast Earth itself, a true legend of exploration.
And what a perfect humbling note to end on. From data centers in our own backyard to a lonely probe tasting the space between stars. What a day for astronomy news.
It certainly was. To recap, we discussed Google's orbital ambitions, a traffic jam in space, a rogue planet shaking up our past, Mars's surprising influence on our climate, and Voyager 1's incredible lonely journey.
Thanks so much for joining us on Astronomy Daily. We'll be back tomorrow with more news from across the universe. Until then, keep looking up.
Clear skies.
Astronomy.